All right, now we're on part 2 for today, and there's 3 total parts. This first one is basically what to do if you're graphing this y equals ax squared and a is larger than 0. In other words, it is positive. So I'm going to want you to copy these things down, so pause the video, of course, when you need to. And using different colors is good. As you can see, there's 3 different graphs on here. So on this first one here, on the top, I have it in blue. I wrote here that y equals ax squared is referred to as the parent function. So it's your basic function. It's just a is equal to 1 and in this one. So it's 1x squared. You could also think of it as just y equals x squared. Okay, so the a, if it's not 1, is doing something else to it. So let's talk about that. So look at the green right here. It looks much more narrow. And that is because a is greater than 1. So if you have that situation, a is greater than 1, the graph is being stretched. As an example, if I put a 2 there, that would be a stretched graph. It might look like this. And we would say it's being stretched by a factor of 2. So it's a factor of whatever this number is right here. If that was a 3, it would be a factor of 3, and it would be even more narrow. Now the red almost looks like it's being flattened. So it's not negative. That's the a I'm talking about now. A is not negative. It's between 0 and 1. So you'll normally see it as a fraction, but it could also be as something like 0.5, for example. When that happens, we say the graph is being shrunk, or kind of flattened, or squished. It's wider, okay? So, this is a little mistake. I should have changed that. I thought I did, but this right there should not be that, and I'm not sure I can change that right here, or maybe I can. So that should be 1/2 right there. Okay, so didn't realize I could change that as we're going. Okay, so that is, and it doesn't like that. It wants me to make that capitalized. Anyway, so that is being shrunk. So 1/2 x squared makes it wider. Okay, and it's being shrunk by a factor of 1/2. Now, I'm going to go ahead and scroll this down to my next slide. And let's just kind of put it right there. All right, so on this one, you can see this is kind of assuming that a student is going to do this by hand. And I'll go over this, but I'll actually expect that most people will do this work with Desmos. And I will be doing that in my 3rd video. Okay? So on this one, it says graph g of x equals 2x squared, and then compare the graph to the parent function, which is f of x equals x squared. Now the reason why this says g and that says f is that you're just not supposed to use the same letter because these are 2 different equations. You could also, though, just say y equals on both of them. So if you were doing this by hand, you'd make a table of values. You could do this horizontally, like they do it right here, or up and down, which was called vertically. Now, I suggest when you graph lines to make find 3 points. So you find 3 values of x. When you're doing parabolas, it's a better idea to pick out 5. And hopefully the middle one turns out to be where the vertex is. So it's a good idea to choose -2 through +2 and go from there. So what they did here to get these values, they took this value of x, in this case a -2, and put it into this equation here. So -2 squared is +4, and then they have to multiply it by 2. So they got an 8. And they do that for each step along the way. For example, -1 times -1 is 1, and then 1 times 2 is 2. Notice because we're squaring, the negative goes away. So it goes 8, 2, 0, and then back to 2, and then an 8. Once you have a bunch of points, you plot them, and then you draw a smooth curve. So that's what it is right here on the left side. The parent function is the black graph, and the blue one is the new graph. That's the g of x. And you can see some information here. It says both graphs are going to open up. I'm doing this because it says to compare them. Okay, so both graphs are opening up. They also have the same vertex, which is 0, 0, and the middle of them is the same. So the axis of symmetry is x equals 0 on both. And this x will always be the same number as the first number of the vertex. And then finally, the graph of g is narrower than the graph of f because the graph of g is a vertical stretch. How much? It's a factor of 2 because there's a 2 in front of the x squared. All right? Now, that's how you would do this by hand, but on my third video, I will show you how to do that with Desmos. I'm going to scroll down now. And the other thing we needed to talk about today, let's see if I can fit all this in here. I might have to squeeze this down just a little bit, or a lot. Let's just do it this way. Here, I think that's the whole thing there. And that's pretty good. And I'm going to adjust a couple things. Oh, I guess it's not letting me change that, so I'm not going to play around with it too much right now. So on this example, a is less than 0. So I put a little note on the top. When a is negative, so it's less than 0, the graph is reflected across the x-axis. I like to call that flipping down. So you might hear me say it's flipping down, but your book is going to say it's reflected across the x-axis. So in the blue this time, we just have negative x squared. That means a, in this case, is negative 1. So it is not being stretched or shrunk, but it is being reflected across the x-axis. So it's opening down. That's the only change from the parent function. For the green this time, we've got y is equal to negative 2x squared. So notice it's less than negative 1. So it's not only being stretched, so it's more narrow, it's being like pulled down, but it's also being reflected across the x-axis. Finally, on the red, it has to be between negative 1 and 0. So it says y, as an example, equals negative 1/2 x squared. Two things are going on. The 1/2 is shrinking it, so that's like flattening it out or widening the graph. And it's also being shrunk by a factor of 1/2. Okay, so it's being shrunk by a factor of 1/2 and reflected across the x-axis. Okay, I'm going to go ahead and move on to my last thing here before I switch to or finish up this video. So in this particular example, we're graphing h of x is equal to negative 1/3. So I know the negative is going to move it down or flip it down, or like they like to say, we reflect it across the x-axis. So we do the same thing, and it does get a little tricky sometimes with fractions, but if you're careful, you can put in values. Notice they put in not negative 2, negative 1, 0, 1, and 2, but they put in some other numbers because as you do this more, you'd realize sometimes if you put in a negative 2, you might get a fraction or a decimal. So these are the numbers they put in that would definitely not give them decimals. So you go through the same process, but now when we compare them, you can say they do have the same vertex, 0, 0. They still have the same axis of symmetry, which is that going right up and down in the middle. But h is opening up down while f is opening up. That's because the parent function has a positive number out front. The h function has a negative number. Also, the blue function, which is h, is wider. So it is being shrunk by a factor, and that factor is 1/3. All right, I'm going to go ahead and stop this video, and on the next one, I'm going to do some of these with Desmos.